All right, in this video, we're going to be talking about initializers. There's three main types of initializers: array initializers, collection initializers, and object initializers. Initializers are really just a way to initialize things in a very convenient syntax. You'll see me use them a lot because they're just, once you know about them, they're way more convenient than writing the code that they allow you not to write. So let's go ahead and jump into a console application and take a look at initializers. So we're going to take a look at array initializers first. So basically, anytime that you're declaring an array, either as a local variable or as a field, you can initialize it to an initial amount of values. And that amount of values is obviously an array. Once you set the amount of values, it can't be changed. But what we can do is, there are two ways to do this. That we have the non-implicit and the implicit initializers. They have different names to them in the specification itself. But the non-implicit way is to explicitly define your type, followed by square brackets to denote that's an array, obviously. Give it an identifier, and then assign it to a list of things. And that's it.
Of the type specified.
Yeah, of the type specified. These obviously have to be integers or convertible to integers.
Mm-hmm.
So now we have an array that is filled with this data, and that's all the code we had to type. The second way to do it is a little bit nicer, in my opinion, just because it keeps, when I'm using arrays, it keeps the var keyword to the left and left aligned with all the other local variables. So it's a little bit more wordy, though. Basically, we do var array2 equals, then do the new keyword, followed by the square brackets to denote that's an array, then immediately followed by curly braces. So now we can do 1, 2, 3, 4, 5, and have ultimately the same array. Now the interesting difference between these two things is this one is explicit. We are explicitly defining the type. This one isn't. This is implicit typing right here because we're not actually passing in or we're not actually giving the new operator any type to work with. Now, we could, of course, but that's redundant because without the type specified, we can keep things nice and implicit, where the C# compiler will see all of these values that we're passing into the initializers. And remember, these aren't just necessarily values. These could be expressions, such as mathematical expressions or method calls or whatever you need. But the C# compiler will go through and make sure that all of these objects are of the same type. And if they are, that's going to be the type of the array. And if I hover over the var keyword, you'll see that system.int32 array is the type of array2. Mm-hmm. Now, the important thing to know about this, though, is that let's say you have two classes that implement the same interface. Let's say interface I interface, because I like that name. It's irrelevant what the interface does. It's irrelevant what the classes do. But this is a very important point. And the only thing I don't really like about array initializers, but still. So let's create an array 3. And let's pass in a new class 1 and a new class 2. Now, you might be going, wait a sec, why is there an error? Class 1 and Class 2 can both be converted into their base type, INterface. Unfortunately, that's not how the C# compiler will work. It will not try to convert or coalesce or do anything to make these different, or to make these the same, sorry. Just because that sort of calculation gets very complicated once we start dealing with multiple interfaces and blah, blah, blah. There's no way for the C# compiler to even determine the type of this array. So it's not going to be able to do that. You have two options in this case. You can either explicitly define the type of the array, such as this, in which case now the C# compiler will go out and attempt to coalesce both of these types into the type that we specified the array should be. Alternatively, the more verbose syntax would be to cast explicitly each one of these arguments as an INterface, or one of them as an INterface, sorry. And that part is, it's kind of a lot grosser, essentially. I would just generally stick with doing an explicit type declaration. If I run into a situation where I have an array initializer that can't figure out what I want it to do. So that's pretty much all array initializers do, except for in the case of multidimensional arrays. And the syntax for multidimensional arrays are actually exactly like this, with a few differences. That was a terrible sentence. But they're very similar in that, for example, if I were to do the first example as a two-dimensional array, I could do this. I could say int and then put a comma inside of the brackets. And then I can do array4 equals, and then this is the important part. Now in every element actually needs to be bracketed, and I need to pass in 2 or however, well, I'll get to that in a second, at least 2 different items of any type. And I can just keep on going on and on and on. Next, we have the implicit multi-array, multi-dimensional array syntax, which is, you probably guessed it, virtually the same. And then the same is going to be true for this with the explicit type name. The final thing to know is you can specify numbers inside of these brackets if you want to, including these brackets. For example, I could say this is a 10-item array, or not, sorry. If you explicitly define the type, you can specify the amount. But if it's anything different than the initial, how many items you put in the initialization list, you'll get an error. Okay. And there's really no reason to, because the compiler can determine that at compile time how many items go into whatever array you're trying to initialize. So defining the numbers inside there is pointless. So yeah, are you guys good?
Yeah, that makes perfect sense.
That's perfect. So you want to move on to collection initializers?
Yes, the next item is collection initializers, and those are a lot more complicated. So I'm going to nuke this code because we're going to be writing a lot of code to look at this stuff. And collection initializers are kind of funky, but in the simplest sense, we can initialize a new collection pretty much exactly as we did with that array. So we can say 1, 2, 3, 4, 5, 6, or well 5 because the last one had 5. So this is the same sort of thing, except for we're doing it on an object. Remember, an array is a built-in .NET type that gets special treatment by the C# compiler, so it gets away with doing, its own special syntax. This is not. This is a list. This is part of the BCL. The C# compiler doesn't care that it's a list, but what it can do, because of the way the list is written, it can take advantage of this syntax. What this syntax is actually doing, it's actually very interesting. What it's doing is it's first creating a temp list item, like this, and then it's repeatedly calling the add method for every single item that we add. And then finally, actually I'm just going to get this to this 2. And then finally it initializes our final variable. So this is basically shorthand for that.
Okay.
So, I mean, obviously you can kind of see, why you might want to do this in certain cases, because calling add repeatedly is just obnoxious.
Right.
So that's list initializers, and list initializers aren't the only kinds of initializers we can take advantage of with collection initializers in general. We can also do dictionary initializers. So to do that, it's pretty straightforward again. Create a dictionary, we set some types, and then we do more curlies. And the funny thing about this is a dictionary, it doesn't work like a list. It needs both a key and a value for every item. So we use curlies to pass in, just like a multidimensional array, we use nested curlies to pass in both the values that the dictionary expects.
So is it like one pair of curlies for each key value pair?
Yep.
Okay.
And basically, I'm just going to write this out as quickly as possible because the point is pretty straightforward. That basically just turns into this. So yeah, that is so far how you can use collection initializers with the BCL. But remember that I said that dictionary and list don't get any special treatment from the C# compiler? That means you can actually write your own classes that can take advantage of this syntax.
Okay.
And the idea is and this is going to seem kind of counterintuitive at first, but let's go ahead and create a class, and we're going to call this our custom collection class because we're writing a custom collection for whatever reason, and we want to take advantage of the collection initializer syntax. Now, in order for this to work, you would assume that all you had to do was make an add method, right?
Mm-hmm.
You assume that that's all it takes to to work with the collection initializers. Unfortunately, that's not the case, because if I do this, and I use the syntax right here, we do get a little bit of indication that it might work, but it's not going to. Look at this. Cannot initialize type custom collection with a collection initializer because it doesn't implement IEnumerable.
Yeah, well, the bottom line is that class, all because you called it custom collection, it's not a collection.
Well, what do you mean? Well, yeah, exactly. It's just
I can't believe you even said that just then. But
well, no,
okay.
I was like, no, it is a collect. Oh, no, I know what you mean now.
Okay.
But the funny thing is this, the C# compiler, actually, this was a design decision made by the C# compiler team.
Mm-hmm.
Basically, what happened is they came up with the awesome idea. Let's add collection initializers. They'll just repeatedly call .add on all the items that we pass into them. But wait a sec. There's a lot of other items in the BCL that have add methods that have nothing to do with collections, and we don't want people abusing collection initializers to do things that we don't want them to do.
Mm-hmm.
Their next step was, okay, what classes do we want to work with collection initializers? They found, well, obviously all the collections. Unfortunately, not all the collections in the BCL implement a common collection interface. Instead, the only commonality between all the collections in the BCL is that they implement IEnumerable.
Mm-hmm.
So what they decided was, we don't want people to abuse this. We don't want people to come up with cute little add methods in math libraries that use this syntax to mean something it shouldn't. So instead, we're going to artificially impose a restriction saying that whatever class we use with the custom or with collection initializers has to implement IEnumerable. So if I go ahead and up here and do IEnumerable of type int and implement the members real fast, implementation is irrelevant there. We now see that the code compiles.
Very nice.
Now, there's one more thing. Just as you saw with the dictionary, remember I said that dictionary and list don't get any special treatment, and they use the exact same fundamental feature of the C# language. And if you look at this syntax right here, this is actually passing in 2 values into the add method, which we can do with our own custom code. We can do 3 or 5 or 10 or however many, but obviously there's a limit to people's sanity. And we use that, or we do that.
We use the same format that we use
use the same
basically
format
as
that
you
we
saw
used as
with
the
dictionaries,
dictionary.
etc.
So we pass in 1 and then 2
Nice
and then
recovery.
3.
What was that, Zach?
I said nice recovery.
I'm sorry, he was really dying.
He's kind of swimming there for a minute.
And you'll see that that is completely valid.
Yeah, can I go ahead and hit compile, and you see build succeeded.
Yeah.
And again, this will just boil down to a bunch of add calls on this. So it's a great way to save a bunch of time.
Absolutely.
Okay, so now I'm going to nuke all this code again because there's one more type of initializer that we need to go over. And it kind of also ties back in a bit to collection initializers, which we'll see. So I'm going to delete all this code, and I'm going to delete all this code. And the next type of initializer is the object initializer. The object initializers are really cool because what they allow you to do is initialize all of the properties, or as many properties as you wish to, of an object when you instantiate it, without having to repeatedly use the object's name in order to set properties.
Mm-hmm.
So let's go ahead and write a class called name. Name's a good, or let's call it, I have a better idea, person. And let's give him some properties. So we have a first name and a last name. Note that I give these properties both a public getter and a setter. Now what I can do is, well, in addition, I can call the constructor, if there was one. So your ability to call the constructor is not impacted whatsoever. In addition, this is an instance where the parentheses that you usually have to do when invoking a default constructor of a class are actually unnecessary. And the interesting thing is there's actually no reason why those empty parentheses aren't necessary at all, except for, according to one of the lead developers on the C# team, they just don't have the time to implement that feature all across the board. But in this case, they decided just to go ahead and do it for this one instance. So you don't need parentheses on the end of a default, or on the end of a class to invoke the default constructor as you normally do. But if you put in curlies right here, what you'll get is, and I'm going to go ahead and hit Control Space to bring up IntelliSense, you'll see that we now can access all of the properties of this person class right here. Not only that, well, I mean, that's about it actually. But to show
Nice.
you,
Thank you.
to show you what it would look like if we don't have the syntax, it would look pretty ugly. First of all, first difference, you have to have the empty parentheses to invoke the default constructor for whatever reason. Then you have to say person2 dot first name equals hey, and person2 dot last name equals stuff. And that's just redundant and ugly, and there's a lot of code that's just being wasted. I mean, we're saying person2 twice. Imagine if we had 10 properties we wanted to set.
Right, exactly.
And that it doesn't stop at simple value types. We can actually nest not only collection initializers and properties, but also other object initializers in object initializers, which is cool. One of the limitations we do have, though, is let's say a person also has a public person favorite person, right? And let's say, hey, stuff, his favorite person is himself. This is not valid. Normally, it would be. If I were to use this syntax down here, I could say person2 dot favorite person equals person2. That's completely valid. But in an object initializer, you cannot refer back to the identifier that you're setting your new person to. That has to do with just the decision that the C# compiler team made was they didn't want a object to be initialized in a half state. And basically what they're doing is they're assigning this object to a different temporary variable, setting all the properties on it, and then setting this new R variable that we want to that temporary variable.
Right.
As a result, we don't have access to that temporary variable. Therefore, circular references are not allowed.
Makes sense.
But they are allowed if you were to do this.
Because it's already initialized at that point.
Yeah, it's entirely initialized. It's available. You can do whatever you need to do with it.
Exactly.
The next thing that is very interesting about object initializers is you can actually use collection initializers inside of object initializers, which is really cool. So basically, let's say we have a list of string, and let's call this addresses. And let's give him a public getter, but a private setter. And let's go ahead and create a default constructor that just initializes him to a new list. Okay? And this actually brings up 2 points. First of all, this default constructor is still getting called. Not only is it getting called, it'll be getting called before any of these properties are set. Which means the addresses will be initialized before the object initializer gets around to doing things. So we'll go ahead and comment that out because it's throwing an error. And now I can go and look at addresses. Or not. Does it not work with automatic properties? Maybe not. That would be news to me. And very disappointing, to be honest. Let's go ahead and give this guy a private field. Assign it to that. And then give this guy a public getter that returns out our address private field. And let's see what shows up now. Well, I just learned something new.
Awesome.
Okay, so quick caveat. You cannot use collection initializers with automatic properties.
Well, there you go.
But you can use them with non-automatic properties. And in this case, we have it's just returning without a private field, but and as a public getter. Oh, I guess that really makes sense in a very.
Makes a lot. No, it just makes sense. Period. If you stop and think about it.
But see, here's the thing, though. We're never actually accessing the setter because the setter doesn't even exist here. But I don't know. They have their reasons. I trust in the C# compiler team. They are always right. So basically, we can use collection initializer syntax here, and just like normal. So we can say 1, 2, 3. And the funny thing about this isn't actually assigning addresses to anything, which is kind of weird considering every single other case is actually assigning something to something. Instead, this is just calling the addresses.add method multiple times, just like you saw before with collection initializers.
Right.
But the important thing is you can see we don't need a new list here. I mean, yeah, so yeah, that's pretty much object initializers.
Okay.
Cool.
Now, that was pretty much all of the initializers that you set out to talk about, right?
Yeah.
I mean, that's everything.
Those are all when creating variables, when instantiating variables, those are the 3 ways that you can save a lot of time.
And I'll tell you, they are awesome. I love them.
Yep.
Okay, so with that, we'll go ahead and wrap this video up, and thank you all very much.